Now we are discussing about analog to digital and digital to analog conversion necessity. Why we need to convert an analog signal to digital signal, and what is the necessity to convert a digital signal to analog signal. Before knowing that, first we have to understand what is analog signal and what is digital signal. Any signal which is continuous in time and which is continuous in amplitude, we call that kind of signal as analog signal. That does not mean only this sinusoidal signal is only the analog signal. The speech I am speaking, the English language I am speaking, whatever the information you are hearing with your ears, it is nothing but an analog signal. The light we are receiving, it is nothing but it is an analog signal. If it is summer in the coming 1-2 months, if we feel some suffocation, if we feel the temperature is being increased drastically, that temperature information is an analog signal. Sometimes if you observe the pressure, water pressure level, that itself it is an analog signal. There are many signals which we observe through our 5 senses in the nature. The chalk piece I am touching, this is nothing but this is an analog signal. This information my skin is carrying. So these types of analog signals are abundant in nature. So generally the signal might not be like this only. This is an analog signal. That might not be periodic signal. This is an aperiodic signal, but still it is an analog signal. Okay. So we mentioned that when we can say a signal is an analog signal, when it is continuous in time and when it is continuous in amplitude, that kind of signal we can call it as an analog signal. But the problem with this kind of signal is, here I am giving 0 in time and this is 1 and this is 2 seconds. If I ask between 0 and 1, how many time intervals we have, means the answer is infinite. Infinite time intervals we have between 0 and 1, and infinite time intervals we have 1 and 2. And if I take the amplitude, this is 1 and this is 2. This is the amplitude, the peak amplitude is 2 volts and the negative peak is minus 2 volts. But if I ask the question, between the 0 and 1 volts, what are the different voltages we have? It is varying, infinite. Between 1 and 2, how many voltages are there? Infinite. So this kind of signal is an infinite amount of information is required to store this signal. So that is what we are perceiving with our eyes. That is what we are actually perceiving with our ears. The beauty of our senses, we are perceiving as real as it is. The analog signal we are perceiving. But the computers, your camera, will not see as human eye. How much megapixel the camera might be, how much costly your phone might be. That might be 1 crore phone, or that might be 100 crores computer or 100 crores digital camera. But human eye is capable of capturing this information in analog way. But your camera is capturing that information in the digital way. So here, why we are going for the digital signals? There is no doubt we are having, if we want to store this signal, infinite amount of information we have to store. Now what we are doing, in order to reduce the information we have to store, we are taking only some time intervals. These are only some time intervals. 1, 2, 3, 4, 5, 6, 9, 12. Out of infinite time intervals, I have selected only 12 time intervals. With these 12 time intervals, I can reconstruct the signal. This was told by the Nyquist. The maximum frequency, if it is f, then how many samples you have to cut? 2f samples minimum you have to cut in order to reconstruct the signal. That is what you might have studied in the sampling theorem. So Nyquist told there is no need to store these infinite samples. There is no need to transmit these infinite samples in the time domain. Nyquist told, instead of infinite, I will reduce the number. For that I am telling you one sampling theorem. So here I am only sending 12 samples in 2 seconds. Instead of infinite samples, we are sending only 12 samples. That is the power of the discrete signal. This is not a digital signal, still it is discrete signal. This is discrete in time domain but continuous in amplitude domain. This is continuous in time domain and continuous in amplitude domain. This is called as analog signal, also called as continuous signal. This is a discrete in time domain and continuous in amplitude domain, but still the problem exists. There is no doubt we are sending only 12 samples, but each sample when we are sending in the voltage domain, again we are having the infinite amount of samples, infinite amount of information we have to process. Compared to continuous or analog signal, in the discrete signals, we have reduced the amount of the storage. We have reduced the amount of samples we have to transmit. But still the problem exists. So then we thought, why can't we apply this sampling to the amplitude domain? Why can't we take only few samples in the amplitude domain? Then they came with the concept of quantization. So with this concept of the quantization, they made a fewer samples in the amplitude domain. Now instead of the infinite samples, I am taking only some 4 samples in the positive and I am taking only the 4 samples in the negative. I am calling the first sample as 0, 1. I am calling the second sample as 1, 0. I am calling the third sample as 1, 1. Last sample as 0, 0. 0, 0, 0, 1, 1, 0, 1, 1. Binary information. I can also take 0, 1, 2. And then instead of only binary, I can even take the 3 numbers 0, 1, 2. Then the combination I can start with 0, 0, 0, 0, 0, 1 and 0, 0, 2. This is 0, 0, 0, 0, 1 and 0, 0, 2 and then 0, 1, 0, 0, 1, 1 and 0, 1, 2. Then this type of system is called as, we are using a 3-number system. Tripler system, not binary system. Similarly, we can use the 4 numbers. Then that is quadra system. Like this we can. But the most famous one is the binary system. Because why we are going for the binary system means our transistor is capable of switching to level either 0 or 1. In the memories we are, semiconductor memories we are using, it is difficult to get 0, 1 and 2. So when we are using the transistor, either we can use it in the on state or off state. In the mobile, you are using the processor called Snapdragon. In that we have 3 crores of the transistors. So each transistor is working either in 0 state or 1 state. either in cutoff region or in saturation region. So now, when we have completed this quantization, now the signal which we got is nothing but a digital signal. Only 3 levels. Now I can write this digital signal as first sample value is 0, 1, second sample value 1, 0, third sample value 1, 1, again 1, 0, again 0, 1. This is my signal. Instead of sending this signal, I have represented only the positive half. Instead of sending this signal, we are sending only some numbers. 0, 1, 1, 0, 1, 1, 1, 0, 0, 1. When we are sending only this kind of the numbers, our ability to send the data will increase. We can send the more amount of the information through our mobiles. We can send more amount of the information from here to America. That's how you are accessing the information either through Google or simply from your phone. That is digital information. There is no doubt, whatever the analog information I am speaking, when I speak through the phone, it might not be the same voice. When we are recording this lecture in the digital form, you might not hear my voice as clear as you are hearing with your ears now. That is absolutely correct. But whatever we are speaking, that the content is not changing. You are able to understand. That's what we require. Because of that, we are storing huge amount of the capability of our storage devices. That's the need for converting analog signal to the digital signal. But in real time, again, we have to process with the analog signals only. Then again, we are converting these digital signals to analog signals. When we are recording our lecture, the camera is recording my voice in the digital form. But when you are listening to my lecture, your speaker, your phone speaker is converting that digital form information to analog form sound. The sound you are hearing with my phone, with your phone, is an analog signal. But in order to give that analog signal, whatever the equipment we are using for the recording, it is in the format of the digital. So we require the conversion from analog to digital and digital to analog. That is requirement in our daily usage of electronics. For the real-time information, in the nature, whatever the signals we are seeing, they are not digital signals. Any signal you observe, that is only analog signal. Most of the signals you are seeing in the nature. But for our processing, our computers can store digital signal. Now what we are doing? We are converting these analog signals to the digital signals. We are storing those signals. When we want to see that information, example one video, you are thinking that video is stored in the computer, but the computer never stores any video. Computer stores only digital information. Electrical low and electrical high. Computer does not know video. But when you are using an application like some VLC media player, that application is again with the help of your speaker. That is again giving an experience to you that this is like an analog signal. You are listening to that video in the computer. So for that storage, the information we are storing is very much less. In order to access the real world information, we have to convert the analog signal to digital signal, and again this digital signal, in order to interface with that information, we have to convert again the digital signal to the analog signal. We will observe some of the important points. What is the necessity for analog signal to digital signal conversion? The first point is, when we are using the analog signal, it is more prone to noise. It is more prone to noise. Example, you are listening to my voice. Directly, if you record this analog signal without any noise filter, that analog signal will be affected to noise. But when we convert it into digital signal, it will reduce the noise, and the effect of the noise on the digital signal is minimal compared to analog signal. We are not saying the digital signal is not affected by the noise. We are only saying, compare it to analog signal, digital signal effect of the noise is very much less. That is one important point. And before processing the signal, it is difficult to process analog signal. Infinite amount of data on the time domain and infinite amount of data on the amplitude domain. How much difficult it is processed. They have given you for electronic circuits some 5,000 pages textbook to you. You feel how much difficult it is. Now one person came and saying that you read this 50 pages book. That is digital. Instead of processing this infinite amount of data, we are processing only small amount of data. In order to process the small amount of data, we have to convert the analog signal to digital signal. Data processing is easy and data analyzing is easy. What is there in that data? Even if we want to apply some filters, it is easy to apply those filters to the digital signal. And when you want to store, it is easy to store the digital signal. Next, we are discussing about the precision and accuracy. We can store the digital signal with very much high precision and accuracy, but analog signal, it is very much difficult. And present modern day digital signal processing algorithms, the modern algorithms, they can work on our signals, digital signals. But on analog signals, we cannot apply any modern techniques. So it is difficult to modify the analog signal, but it is easy to modify the digital signal. Example, I want to control some motor here. With the analog signal, if I want to control the motor, it will be very much difficult. That's why generally we use the sensors. They might take the analog data. But in modern day scenarios, we are converting that analog data to digital information. Then the sensor is sending that digital information to any microcontroller. That's what when we are using either Arduino, Uno or Raspberry Pi. These controllers process these digital signals. So it is required whenever we want to control any real-time load like motor. Whenever we want to control any real-time load, then we have to convert the analog signal to digital signal, and again we can convert the digital signal to analog signal. Next, compatibility. The computers, they are compatible of understanding the digital signal but not analog signal. Transmission is easy with the digital signal but not with the analog signal. Due to these reasons, we are converting a signal from analog to digital. That might be my voice, that might be video, and again after processing, this is processing, we are again converting this digital signal to analog signal at the receiver end. This is at the transmitting end. So these are the necessities why we are actually converting analog to digital and digital to analog. Once again we are discussing real world information, we observe only the analog. But these analog signals, it is difficult to process. I told many reasons. So even though the real world signals are analog, because they are difficult to process, we are converting them to digital. The analog signals are being affected by the noise compared to digital. It is easy to process the digital signal, or to store the digital signal, or to analyze the digital signal, or to filter the digital signal, or to apply any modern day methods for the digital signal compared to the analog signal. And the transmission also easy for the analog signal, for the digital signal compared to analog signal. Because of these reasons, we are going for analog to digital conversion. But at the receiving end, again we have to observe the analog signal only. That's why again we are converting digital to analog signal.